Hello and welcome to my YouTube channel. This is my very first tutorial video, and in this video I'm going to be giving a brief introduction into organic chemistry. Here I have the outline of what we'll be discussing in this tutorial. We'll be discussing the definition of organic compounds, what are organic compounds, the carbon atom, hybridization, and classification of organic compounds. Now, anytime we hear the word organic, what comes to mind is something made from plants and animals. So we hear things like organic skincare products, organic hair creams, and all sorts of things. Organic products are generally products that are made from living things, plants and animals. So organic chemistry is the study of organic compounds, and in earlier discoveries it was assumed that organic compounds were made from plants and animals. The assumption was that organic compounds could only be synthesized in plants and animals. In fact, there was an idea that living things have a force that enabled them to synthesize organic compounds. This idea was the idea of vitalism, that living things have a vital force that help them synthesize organic compounds. But further discovery showed that organic compounds could actually be synthesized or produced by geological processes and other artificial processes, and it can actually be synthesized in the lab. So organic compounds are not only restricted to living things, but a key distinguishing factor or something that stands out for all organic compounds is the presence of the carbon atom. All organic compounds contain carbon as a constituent element, all organic compounds. But it's good for us to take note of the fact that all organic compounds contain carbon, but not all carbon atoms are, not all carbon compounds are organic compounds. Now, I'll give the example of very common carbon dioxide, CO2. Carbon dioxide is a carbon compound, but it is not an organic compound. Another example is carbon monoxide. Carbon monoxide is a carbon compound, but it is also not organic. Now, we also have an example like calcium carbonate. Calcium carbonate contains carbon as a constituent element, but it is not an organic compound. So very briefly, I will take us through the carbon compound as an element. The carbon as an element, rather, not carbon compound as an element. So let's look at carbon as an element. Carbon is the sixth element of the periodic table. It has 6 electrons and 6 protons. Now, the electronic configuration for the carbon atom is 1s2, 2s2, and 2p6, 2p2. Now, as we can see, when we add the superscripts, they equate to 6. Now, of course, we know that the p orbital contains 3 subshells. That's the 2px, 2py, and 2pz. Now we also have here the 2s, and we also have here 1s. Now, drawing out the electrons, it will look something like this. And here we have one and another one. Now, in the excited, this is carbon. This is the electronic configuration of the carbon atom in its non-excited state. When carbon atom is just at rest, it is not excited. This is how the electrons are configured, how they are arranged in the orbitals. Now, in the excited state of the carbon atom, this electron gains energy and then it is brought to this particular subshell, the 2pz. So in the excited state, this would remain the same, but then we would have something like this. 2s would be converted to 2s1 with just one electron in it, and the second electron would be here in 2pz. So this is 2px and 2py and 2pz. Now, before we continue here, this idea would lead us to hybridization. But the carbon atom is very peculiar in the sense that it exhibits certain qualities or certain characteristics that enable it to form such a wide array of compounds. One of this ability of carbon is its ability to catenate or catenation. Now, catenation is basically the ability of an element or the ability of atoms of an element to link. It's simply self-linkage. So due to this particular characteristic of the carbon atom and the carbon element, carbon atoms are able to link and form long chains and long branched chains and long cyclic compounds. This is a very key characteristic of the carbon atom. Another one which we'll later look at is the ability of the carbon atom to form hybrid orbitals or hybridization. This is another quality of the carbon atom that enables it to form such a wide array of compounds, hybridization. So we'll come back to hybridization, but another quality is, or also falling under catenation, is the ability of the carbon atom to form double bond, single bond, and triple bond. This is also attributed to both catenation and hybridization. So let's move on to hybridization. What is hybridization? So for some of us, we might be familiar with the term hybrid or hybridization, and whenever we hear that something is a hybrid, it's basically a combination of different things. A combination, for example, in genetics, we have hybrid organisms that are made from like two parent organisms that have different genetic makeup. Hybridization of carbon atoms, or of hybridization of the carbon atom, is similar to this. So earlier we looked at the 1s2 and the 2s2 and the 2p2, and I earlier stated that the carbon atom in its excited state, one of the electrons in this particular orbital moves on to the subshell of the 2p orbital, forming something like this. Now, we can see, of course, here that the electron that was initially here has now moved to 2pz. This is carbon in its excited state. Now, although this electron that was originally here has now been moved here, it could still lose its energy and move back here. Now, these two orbitals, 2s and 2p, are not degenerate orbitals. Degenerate orbitals are orbitals that possess the same amount of energy. However, 2s and 2p are not degenerate orbitals. Now, what hybridization does is that it combines electrons from 2p, or rather 2s and 2p. It combines these electrons and it produces a hybrid orbital that is degenerate. So carbon atoms generally form 2p3, or rather sp3, sp2, and sp hybrid orbitals, and I'll explain how these orbitals are formed. Now, for sp3, you can imagine, or the s has an imaginary 1, but it's not necessary to write out the 1, but it has 1 and p3. What this simply means is that one s orbital combines with 3 subshells of the p orbital. Now, in this case, it means 1s. This is just an s orbital. The s orbital has only one subshell, so 1s combines with 3p, so it combines with 1, 2, 3. Now, I earlier stated that these orbitals are not degenerate. The 2s and the 2p are not degenerate, but when hybridization takes place between one of these and the 3 of these, it forms a hybrid orbital that is degenerate, and that hybrid orbital is the sp3. So this is the sp3 hybridized orbital. Now, how about the sp2? For the sp2, what we have is sp2. We have 1s combining with 2p. So we take this s and combine it with 2p. So 2 of the p subshells. Now what we would have is something like this. 1 sp2 However, we still have the 2pz electron doesn't take part in this hybridization, so it's still left alone in its own subshell. Okay, so we also have the sp. Okay, so I would come over here, and so sp just involves one of this and one of this. So sp, so the sp hybrid orbital looks something like this, but then we still have two of these subshells did not take part in the hybridization, so they are left out. So we'll still have 2py and 2pz. Okay, now we have the sp3, sp2, and sp. Now, for the sp3 hybridized orbital, it has 1 s out of 4 subshells. So of the 4 subshells that are formed, Remember, we had something like this for the sp3, one s, and all of the 3p subshells are hybridized. So we have 4 subshells. Now only one out of the 4 is S and the remaining 3 P. Now in this case we have 1 S out of 3 and we have 2 P out of 3. In this case we have 1 S out of 2 and we have 1 P out of 2. For this particular hybrid orbital, it exhibits 25% S characteristics and 75% P characteristics. For this, it exhibits about 33% S characteristics and 67% P characteristics. For this, it exhibits 50% S and 50% P. So this is just the basic and the general idea of hybridization. Now moving on to classification of organic compounds. Classification of organic compounds. Organic compounds can be classified generally into, so I will just write it out. So we have organic compounds. Organic compounds can be classified into the cyclic and the acyclic. The acyclic is also sometimes called the aliphatic. Some texts have it as the acyclic and some texts use the term aliphatic. So under the acyclic, we have the open chain, acyclic hydrocarbons, or rather acyclic organic compounds have an open chain. They could be branched, or unbranched. For the cyclic, as the name implies, they form a ring. So they form a ring. They could be homocyclic or heterocyclic. For the homocyclic, we have alicyclic and we also have the aromatic. Now, this classification of organic compounds is mostly based on structure. So, for example, acyclic organic compounds, based on their structure, they have either an open chain which could be branched, or an open chain which could be unbranched. And then for the cyclic, based on the structure, it forms generally a ring structure. Organic compounds could also be classified as hydrocarbons and non-hydrocarbons. contain only carbon and hydrogen, and the non-hydrocarbons contain other elements but with carbon as the central element. So they could contain nitrogen, oxygen, sulfur, and could of course include hydrogen here. So this is the general classification of organic compounds. Moving on, just to add on to what we have here as our outline, we also have uses of organic compounds. Organic compounds are used in our everyday life, and the food we eat, carbohydrates, protein, fat and oil, are all organic compounds. Organic compounds are used in making detergents. They are used in making beverages like alcohol. Alcohol is an organic compound. There are a lot of other uses of organic compounds. Petroleum or petrol is an organic compound. Diesel is also an organic compound. We also have some natural gases that are also organic compounds. Cooking gases, organic compounds, and the list goes on and on. So this is just a brief introduction into organic chemistry. I brushed over some things and I was detailed in some areas. However, this is just a general overview of an introduction, and in subsequent videos would look at alkanes, alkynes, alkenes, and all other organic compounds. So please, if you liked this video, please give it a thumbs up and kindly subscribe. Thank you for watching till the end. Bye.